Right, hello and welcome back to another video. Today we'll be carrying on with our Niagara series, looking at an introduction to the Niagara particle systems and sort of an introduction to effects in general. So today we're going to be making a Flipbook material and using that to create some falling leaves. So starting here, just looking at the texture we're going to be using. So a Flipbook is a way of storing an animation into a texture. So here I've animated a leaf just spinning around simply, and then I've rendered out each frame and I've brought that in as a single texture, and then I'm going to play back frame by frame and create sort of the illusion of animation via one texture. This is a 3D model that has been rendered out. There's lots of ways you can make Flipbooks, but I'll just quickly show you. Here I've made a 3D model, two sides, different textures, or different sort of a light side and a dark side on my texture, just to get some variation, and then I just animated it spinning around, and rendered every frame out and composited it together into a single texture. So this has been designed to be a looping flipbook, so we can kind of play our animation through as many times as possible. If we have a look at one of the flipbooks that's in the starter content, so there's a couple here, fire and somewhere an explosion I think as well. Nope, maybe not. Okay, there's just a fire. But there is a flipbook here, and you can see it's a single sort of set of animations, but it's not designed to loop, and so subtle difference between those two there. Cool. Okay, so this is what a flipbook is. This is the texture we're going to be using. Very briefly, how we made it, and so we're going to make a material. So the first thing we need is a material. Just going to create a new one, and all we're going to do in this material is set it to be masked, because we want to have the outline of the leaf. It's not going to be a square, and I'm just going to bring that flipbook in as a texture. And all we're going to do is take the alpha to the opacity mask and RGB to base color. Now you might want to have more control in here in your material, but for our case now this is going to be enough to start with. And you can see here we see our 16 leaves, the 16 frames of our leaves, alphaed out with transparency on the background. Cool. Okay, so we're in Niagara. We're going to create a Niagara emitter. Remember, emitters have the actual particle system. Emitters actually have the particle data in. System contains emitters. So we're going to start with an emitter, and I'm actually going to use one of the templates. I'm going to use this hanging particulates, which is going to give me a load of particles spawning in an area and not doing very much movement, which is a good place to start for this leaf. Now we went over the basics of Niagara and setting some of these things up in the previous video talking about dust, and so I'm not going to go over everything, but the important thing we're going to do here is in Sprite Renderer. So if I go here to the leaf flip material, which is the one I've just created, it's going to have to quickly recompile because it's now applied the Niagara usage flag, and caused the recompile there. But once that's done, we'll now see our particles. Now they're very small. The default size here is 1.5 to 2, so I'm just going to up that to 10 to 15. It's a bit big, 10 centimeters, 15 centimeters for a leaf, but get things nice and visible for the video. Now you can see all 16 frames, so we don't want that. We jump back over to Sprite Renderer. The thing we need to change here is sub UV. So we did use this in the dust example to pick one of the 4 frames at random, and in this instance what we're going to do is pick one, or is tell it to be 4x4. We've got 4 images across, 4 of them up. If I set this to 4x4, now we're just getting that single leaf, which is cool. It's not animating. That's the thing that's not happening next. So we need to tell it to do some animation, and if I go in here, it's particle update is where this animation is going to happen. Something that happens every frame while the particles are live. So we need to have that in the update section, not the spawn section. And if we just type in sub UV, what we want is this sub UV animation. So before we used random, this time we're using linear. All that means is it's got a sort of linear progression of frames, so one frame after another, which is what's going to give us that animation. And the default here is number of frames 4. Well, we've got 16 frames in our flipbook, and you can see now we're getting that animation happening. And there's a couple of things. So firstly, it's what I would call ticking or clicking. It's going from one frame to the next quite visibly. Now we could go back to our render, our simulation, and put more frames in, but there's always this kind of conflict between how many frames you have and how much resolution each frame has itself. More frames, better animation, but less resolution, and vice versa. So there's also this option here in Sprite Renderer. We can turn on blending, and if I turn this on, nothing's going to happen because we also need to use a different material node. And so if I now go back to here, rather than using a texture sample, I'm going to use a particle sub-UV sample. And this is basically very, very similar. You see all the same inputs and outputs, but it has this option here for blend. So it's just got a little bit extra code that allows it to blend between two frames. So I'll swap this one over, like so. And apply the same leaf texture. And now if I compile this, or save and compile this, give it a second. What it's now going to do, rather than going from one frame to the next, it's going to kind of like crossfade them or blend them. So you'll be able to see two frames at once, but not at full opacity. And if we have a look, it's not infinitely better, but now there's this sort of soft fade to them as they're going from one to the other. I'm not personally a huge fan. I don't use sub-UV blending very often. It comes at additional costs because now two frames are being rendered. I would rather just make sure my spawn rate, or my frame rate, sorry, was high enough, or just put more frames into my animation. But it's nice to know it's there. Occasionally you might want to use it for something. So what else do we want to control in our actual sub-UV animation? So here it's playing 16 frames. If I put in a much bigger number, like 64, it's going to increase my frame rate, and it's going to play through, give it a sec, it's going to play through multiple times. So I've got control over how fast I want things to be, but it's not a very nice way of doing it. Personally, I quite like to have a number of frames here to be the number of frames in my flipbook, and then I want a multiplier for how fast things are going to play through. And the current way it's working is it's using this sub-UV lookup index. So how is it looking up in our index of frames, or our array of frames? And it's doing it based on normalized age. So the at spawn our normalized age is 0, at full lifetime at death our normalized age is 1, and so what we want to do is now have a multiplier on this so that we can control how we're looking up in our 16 frames. Nothing wrong with changing this to 64, making things faster. 128 can be faster again, but it's not the most intuitive, I find. So it's one of the things that Niagara is really good at. So we can just create our own little expression in here. So if I take this and I say, instead of doing just the normalized age, I'm going to do a multiply, and I'm going to multiply two values together. Now if I type in age and get my normalized age back, I now have a value that's effectively frame rate. How fast do I want my things to be? And if I change my flipbook to have more frames, I could change my number of frames, and it's going to automatically just kind of adjust for that, which is kind of cool. Now if I set this to 0, there is another problem. Everything's spawning and using the same frame on the same start frame because we haven't told it not to do that. And this is another thing that Niagara can work really well. So if I go into my particle spawn, what I'm going to do is I'm going to create a parameter that's going to be my random initial frame, and I'm going to do it once as the particle gets spawned, and just set that, and then I can look at it in my update and use that to offset my initial frame, my initial sort of starting frame. So if I just do set new or existing parameter, up here we have all the parameters that are involved in the system, and we've been using one, haven't we? We used particle normalized age, there it is, and now I'm going to do and create my own one. So I've gone to set parameters, and I'm just going to click this little plus, and I'm going to create a float. It appears in this list, and we can double click, or F2 sorry, and rename it, or right click, rename here, rename, there it is. I'm just going to call this random start frame, and we can obviously rename over here as well, F2. And we don't want it to be 0, we want it to be a random value, in which case random range float between 0 and 1. Now this has been set once, so now I'm going to change my expression here. Instead of being multiply of these two values, it's actually going to be an add, and then in A of my add, I'm going to bring back that multiply. So the two things I'm multiplying together are my age, particle normalized age, and this frame rate value, which is now open for me to do what I want with. And I'm going to add that initial random value, so random start frame, which is the random value that I'm setting here. So if I set my frame rate to 0, you can see all my particles are spawning on a different frame, and they're not animating because everything's set to 0. But if I set that to 1 or 5, particles will spawn and spin. And you might have noticed with all that typing in of random, if I do it again, there's this thing here, material random, and what this is actually is an inbuilt particle parameter that is a random value between 0 and 1. So it has material in it, and you need this to hook up to the material nodes to create random values in your material, but we can also just use it. It's a random value between 0 and 1 for a per particle. So if I do this and set this to 0 again, it's going to work exactly the same because it's a different random value between 0 and 1. So nice to be able to know how to set our own values. We can do this for whatever we want, but if we do just want a random value between 0 and 1, nothing's stopping us doing it via piggybacking on the material random that already exists, which is kind of cool. So a couple more things I want to add just to sort of finish off the visuals of this, but we've covered all the sort of Flipbooky things that I want. A little bit of initial velocity. So at this point they're just all spawning in the air, not really moving very far. So at spawn I might want to set the velocity, and I'm just going to add velocity and do a random value, and I'm going to make between 50 and 100 centimeters per second in X. It does have drag on it because we started with that template, so you might want to reduce that drag down a little bit, maybe get rid of it entirely. Now they're just spawning along, and we might want some acceleration. Obviously particles or leaves are going to fall in the wind, and if I set here acceleration force, this is in the wrong place. We need to fix it because forces have to come before the solve for forces, but we just click fix and that comes into the right place now. And if I create another random value here, I'm going to have a random negative velocity or acceleration in X to create some sort of falling, and you can see I've created some nice motion there to my leaves. Maybe a bit high, bring that down, maybe a little bit of acceleration in X as well to create some nice random motion. One more thing I want to do at the moment, they're spinning within the animation of the flipbook themselves, but they're not spinning in terms of the sprites. If I change this to shader complexity, got a nice way to see what's happening on your particles without having any information on it. It's a bit too, shader's too cheap, it's hard to see. If I try wireframe instead, there we are. So we're getting our sprites coming out at a random orientation, but they're not rotating themselves. So I'm just going to add a rotation rate, sprite rotation rate. And this is in degrees per second. Turn it to random, and I can say plus or minus 30 degrees. And now they'll spawn and spin. Oh. Well, so actually this is a bit of a gotcha. We've set this to be plus or minus 30, but actually that's not going to work because it's recalculating that every frame. So you're getting this little wobble, but they're never actually rotating. So we might want to use our random value. So here, let's change this. So let's create another random value on spawn. So let's do a float, and I'm going to call this random rotation, something like that. And if I set this to be a uniform float, and I want this to be from -1 to 1, and this is going to be my random rotation rate. So I take this value here, and then in rotation rate multiply it by my maximum rotation, so there's 30. So if I change this from float to multiply, I can set this one to be my random rotation, and here I set that to 30, and now they're going to be some spinning at 30 and some spinning at -30 because the random value here was set from -1 to 1. So in this case we can't actually reuse the material random, without having to do a bit more maths to it. We could set that up, but in this case we just create a random value between 0 and 1 and then multiply it there. So it's quite a nice example of how how Niagara works with data. And so everything in particle spawn just happens once, everything in update happens per frame. And we're getting that spin. If I just up that rotation rate, make it a bit more visible, you can see we're definitely getting spins this way and definitely getting spins that way, so that's definitely working the way we want. Drop that back to lit, have a final look, and there we are. We've created a nice leaf effect, a little bit of motion, and then a lot of animation coming from the Flipbook material rendering as well. So that's where we'll leave it for today. Thank you for joining us, and if you have any questions or comments or anything, let me know. Big thanks to all my patrons who can help me do this for supporting the channel, and I will see you all next time.